Now that you know how to work with both inverse functions and you know how to work with exponential functions, we need to learn to work with a new function called a logarithmic function. So the first thing I'm going to ask you is, if you think about the function that we've been looking at, either growth or decay, doesn't matter which, but the function b raised to the x, if I ask myself, is that a one-to-one function? Well, if I think about what it looks like, I either have the growth function or the decay function. So remember, in order to be one-to-one, I have to pass the horizontal line test. Please remember that if I'm looking at this bottom portion or this leftmost portion of my growth function or my rightmost portion of my growth function, as I look at the end behavior of either of these, whether it's growth or decay, notice that my end behavior is going to be approaching that horizontal asymptote of the line y equals 0, meaning it's going to get closer and closer and closer to a y value of 0 without ever touching it. So even though it may begin to look like a horizontal line, the reality of it is it's continuously approaching y equals 0, so it isn't actually a horizontal line despite its look. So when I ask if this can pass the horizontal line test and it's one-to-one, I'm going to say yes. Remember, these are two separate functions, so both of these functions would pass a horizontal line test. Because they would pass a horizontal line test, they are one-to-one. Because they are one-to-one, I can say that the inverse of my growth or decay, the inverse of my exponential function, does in fact exist. And the inverse is called the logarithmic function. And it is written as log with some base of x. So it's read log base b of x. And the definition of my logarithmic function, if b is greater than 0, b is not equal to 1, and x is greater than 0, then if I have log base b of x, that's equivalent to saying x equals b to y. It's almost as if I'm saying dividing by 3 is equivalent to saying multiplying by 1/3. So they mean the same thing. Same thing here. Writing something as a logarithm is the same as writing something in exponential form, except we have some rearrangement going on. So this is going to be extremely important in order for you to be able to go back and forth between logarithmic and exponential functions, that you have this piece of information right here, that log base b of x is equivalent to b with an exponent of y. So notice that log base b of x is the exponent of b. So if you want to think about it, a logarithm really is just an exponent. It's an exponent that b must be raised to, my base must be raised to, in order to get just x. So I want to right now just look at some examples of going back and forth, changing between my two forms. So I'm going to try to leave that on my screen there. And I'm going to look at, what if I have log base 7 of x equals 24? I'm not doing any kind of solving. Right now I just want to change to exponential form. So if I take this first problem and I change it to exponential form, according to my definition right here, I'm going to use the same base. So my base is going to be 7. I'm going to raise it to whatever my logarithm is equal to, and set it equal to whatever I'm taking the logarithm of. I'm going to do the same thing for example 2. Now, of course, I could put this into my calculator and actually solve it, but right now, again, I'm not solving. Doing the same thing on example 2, I'll keep my same base, I'll raise it to whatever the logarithm is equal to, and set it equal to whatever I'm taking the logarithm of. Finally, doing the same thing on example 3, I'll take my same base, and example 3 would be a good one for you to try if you want to ignore the fact that I gave you the base. But I'll take my same base, I'll raise it to whatever my logarithm's equal to, and set it equal to whatever I'm taking the logarithm of. I not only need to be able to go from logarithms to exponential form, I need to be able to go from exponential form to logarithmic form, which is these next 3 following examples. So let's say I want to take this, I know it's an exponential form because I have a base raised to an exponent, and change it to logarithmic form. Well, I will write out log, I'll keep my same base, I will take the log of whatever I'm equal to. So in exponential form, I'm equal to 4, so I'll take log base 7 of 4 is equal to, I will set it equal to my exponent. Doing the same thing in example 5. Example 5 is going to require an extra step because I really want to be able to get my base by itself, because if I look at my definition only gives me Involved in my definition is only things that I'm taking, that only involves my base, my exponent, and what that is equal to. So I don't want to have that coefficient out front. So the first thing I'll do is divide both sides by 3, giving me a to the x equals, I divide both pieces by 3. It's almost like I'm factoring it out like we've looked at in the past, plus b. Now setting that or changing this to logarithmic form, I'm going to take log of my base, or same base, log, same base, of whatever I was equal to in exponential form. I am going to put parentheses around that to show that I'm taking the logarithm of the entire thing, and I will set that equal to my exponent. And that will be my logarithmic form. One more example of changing to logarithmic form. Great one for you to try if you want to briefly pause the video. Now that you've had a chance to try one on your own, let's see how you did. So I'm going to write log. I'll keep my same base. I'm going to take the log of whatever I'm equal to in exponential form. So log base 2 of 7 equals, I set it equal to my exponent, 5x. That's how I'm going to change back and forth. So extremely important we can change back and forth because we will use this quite a bit in terms of simplifying. Looking at a couple special cases of logarithms, you will often see log of x or log of 2 or log of 3, log of something, and you will not see any base. If there is not a base written, we're going to assume it's base 10 because by definition log base 10 of x is the same thing as log of x. Very similar if we take log base e, remember that's about 2.78, it's kind of like pi, it's just a number. If I take log of e of x, it's the same thing of saying ln of x. So it's referred to as the natural logarithm. Looking at some examples then, so let's say I look at the first one. I want to change to logarithmic form. 10 to the third equals 1,000. Changing to logarithmic form, I'll take log. I'm going to put base 10 of 10,000 equals 3. Well, that's not a bad way to write it. However, the best, most simplest way to write it, and the way I will expect you to write it if you have base 10, is by saying just log of 10,000 equals 3. And then doing the same thing on example 2, changing to logarithmic form, I would write log base e of whatever I'm taking or whatever my exponential form is equal to my exponent. But again, I would expect that you would know that log base e's simplest form is written ln of x minus 4 equals 3t. If you have a chance to look at a calculator, you're going to notice that the only logs written on your calculator are log base 10 and log base e. They are just written as log and ln. So these are very helpful tools, these ideas here, when you be using a calculator to help us calculate what we have when looking at logarithms. Looking at two final examples at the end of this video here, I want to also be able to change to exponential form if I'm given either of these special cases. So let's say I'm given log of x minus 3 equals 4. If I want to change to exponential form, I would recognize that if there is no base written, it's base 10. I raise it to whatever my logarithmic form is equal to, and I set it equal to whatever I'm taking log of. Again, I could solve this for x, but I'm not asked to solve at this point. All I'm asked to do is change to exponential form. And then finally, looking at example 4, doing the same thing, I see I have ln of 3 plus r equals 8. I recognize that if I see ln, it means base e, and when I change forms, I keep the same base. I raise it to whatever my logarithm is equal to, and then set it equal to whatever I'm taking the log of. Again, notice I could now solve this for r, but at this point I'm not being asked to solve, I'm simply being asked to change from one form to another. So that is how you are going to change from logarithmic to exponential or from exponential to logarithmic form. Please make sure you remember your special cases and what they mean. And also please make sure that you know how to convert back and forth between logarithmic and exponential form.